Alright, I know it's been a while, but let's just go ahead and explain the aimbow math. So, obviously we all here want to be some, arrow shooting geniuses, and not all of them, not all of us are, but that's okay. That's why this mod exists, and so here is the explanation of the math. Okay, so to simulate the arrow's flight, we need to know, um, like how to describe it at any single moment in time. So what do we need to know about the arrow, right? We need to know its position, which I will graph like that, right? So we need to know its position. Let's say this is the arc, right? Let's say this is player one, and this is uh, player two. Ew, that is such a nasty color, right? So we need to know its position and velocity, right? So the position being where it's at, where it is, and then velocity maybe being like how fast it's going, you know where it's going, how fast it's going, right? And so the basic principles of aimbow is that it doesn't actually like know Minecraft physics. It knows how to create a simulation and then narrow down those possibilities into something that actually is reasonable, right? So just as an example, you'll have it going, all the way out here, and then it'll slowly, move into hitting the entity, right? Until it has a sort of prediction about how it's going to hit the entity, right? So that's the kind of math that's going into that, and the aimbow basically just takes the successful trajectory and it plots that out, right? So it plots all of these positions that are being stored in the state of the mod and then just graphing that out. So it's basically just connect the dots until it creates an actual prediction for that. And let's just go ahead and oh wow, I haven't even opened it up yet. But let's just go ahead and look at the code here. So let's go to ticking entity and we will have a look. So right now we have the positions, what is it? Position X, position Y, position Z, motion X, motion Y, motion Z. And so these top three, the positions X, Y, and Z, are just the arrow's 3D coordinates in the world. So it would be like these green dots here. And then motion X, Y, and Z would be not just its speed, but like its velocity, right? So that way we can see where it's going and how fast it's going. Um, that way when we launch it, we know what the arrow is doing at each moment that we see it, right? So now that we have, oh, wrong thing. Now that we have our ghost arrow, we have to figure out how are we going to launch it, right? So for all demonstrations in this video, we'll just be talking about the Minecraft bow, right? Because obviously that's what this mod was built around, you know what I mean? So let's just draw out our bow here. I'm not going to make it look very pretty, but if you could stay with me now. All right, so this is our Minecraft bow, right? And first we need to define some stuff about the bow, right? We can pull back the bow, right? So we can pull it back and be like that, and you're gonna add more power to the bow, right? So defining one of the things is the power of the bow, right? So let's just figure out the power of the bow, right? So if we go to bow collision solver, um, what we can see here is, what is it? Where's the use duration? Here it is. Okay, so this is how we generate array data. This is like just a singular point where, like, or like just like data about the bow. We're gonna use the get item into use duration, and it's what is it? We know that like in Minecraft, a bow's um, full draw is 20 ticks, which is just 1 second, 20 ticks per second. If you know, you know. And so we're gonna use uh, what is it? In use duration, math min. Where is that? Use duration. So that's gonna be like the full 1 seconds, and then we divide that by the draw time, and we divide that by 20 to get the draw time, right? So if this is the max that it can go, um, then you have to like basically just find the use duration, and then we use this to make sure that it doesn't go past that. So basically 0 would be like no charge, and then 1 would be a full charge, right? And so then what we do is we multiply this draw time by or basically you cube it, because if you ever notice like in Minecraft when you like draw it back, it gets exponential. It basically like exponentially gets farther. So that's kind of what we're doing here. Um, and then that gives you the force of the bow. And yeah, so basically that. So now let's look at the bow ray data. This is basically for direction. Um, and the shoot method here takes the player's view direction, which is like their rotation yaw. Where is that? The rotation yaw and the rotation pitch. So yaw being like if we had a, let's just go ahead and make a new page here. So let's get this to black and we make this a circle here, right? Yaw would be like, left. What the heck? Yaw would be your left and your right. So it'd be like this range here, and then your pitch would be your up and your down, right? So if you were if this was like your coordinates here, basically where would you be looking? So if your yaw was, you'd have like your yaw up here and your pitch like right here. So then you'd like meet right here, and that's probably where that's where you'd be like looking at kind of. I don't really know how that would. This isn't really like a center thing, but basically you'd be looking. This is where you'd be looking, right? So you get your rotation and you get your rotations left and right, and then you convert that into like the motions. So you use the rotation, you use like a bunch of math here. This was already pre-programmed in. I should probably explain that later. But this is basically just how you convert spherical coordinates, which is like the angle you look at, into x, y, and z. So like if you're hold on, let me clear this out real quick. Actually, I deleted the old thing. Dang it. Anyways, so you'd get your motion x. So you get your x here. Actually, I should probably get that 3D thing back up again. Whatever, it's fine. So you get your thing here, and then you would have your rotation left and right. So maybe if you were angled, up this way, and then that, and then a little this way, right? You'd use like how far, like how much force you've applied. So this is for anyone who's kind of like, I think, taking calculus and stuff. You can it's basically like polar coordinates, I think, but like probably for 3D. Not gonna lie, I don't know, kind of, but I'm pretty sure that's like what it is. So like you'd take your angle that you're aiming at, then you have your force here, and you just find out like what's your motion x, what's your motion y, and you could probably do that for your z somehow, right? You just do like some basic trig stuff. So if you're getting your motion y here, you see like motion y here, it's sine. You get sine, so you take your angle. Let's just do this in 2D real quick, actually. So you do like your motion. So if this was your angle that you're looking up at, and this is your y, this is your x, and your force, this is kind of like your force, like it's gonna go like out this way, right? And it's gonna be like at this x point. Then you can take your motion y, which is sine. So you do like your angle sine, and then you do sine because opposite type shift, and then your cosine here, and then um, for the z motion you just do um, you do like some sine stuff or whatever. I think I completely messed that up, but don't worry. I'm like 95% sure that's how it works. Don't ratio me. Anyways, simulations. I have this down in the script somewhere. I'm like kind of reading it off. So if it's kind of bad, that's because it is. Um, so that now that you have like the force that you're looking at, so now that you have like your force of the bow, like how hard you're pulling it, and then where you're like looking at type shift, you can um you can basically simulate it now, right? So how are we going to trace the arrow's entire flight from point A to point B, like that kind of, because we can't have like a magic formula, because there's just some variance within Minecraft's code. They have like air resistance stuff, which is like kind of crazy, right? So instead the mod will do something just sillier. It'll just obviously simulate the flight tick by tick, and then just calculate the arrow's new position, each tiny step, right? So when you draw it back, right? It'll just simulate like, oh yeah, you've got this amount of draw force, so it's gonna go here. You got this amount of draw force at tick number 5, it goes there. Tick number 6, right? So it just keeps doing that until you max it out, and then it'll show you like where it's gonna land, right? So that's basically what it's doing. And then so let's just go to where it simulates the array data. Yeah, so this is basically where it just where it simulates all of the code. So you get your motion. Where's motion y? What the freak? Where's the gravity thing? Wait. Oh yeah, so get gravity. So you can get your gravity here. This is basically just what pulls it down. And when you have your motion x, where's motion x chat? Am I tweaking? Oh my gosh, I might be. Yeah, so you'd have your motion x, motion y, motion z, and you'd have your air resistance. There's air resistance somewhere in here. Yeah, so like F3, you have your air resistance. F3. This is air resistance. Apparently, they have that in Minecraft. Different objects can be affected by that. So in the code for fishing, potions, and throwables, they're not exactly the same because I think there are different things that affect the velocity or like the deceleration of an object. So these things can vary, but I basically just wrapped it for fishing, potions, and throwables. So that's why like for like the fishing rod, it's not exactly the same. I should probably change that, but I'm not going to because I'm lazy. And it most likely does it short range. So unless you're doing like long range fishing, don't. So yeah. Anyways, and then you just update the positions. Where's the position x? You would set the position to the motion x, motion y, motion z type of thing right here. You set that there, and that would integrate it. So the new position is just the old position plus the velocity for that tick. So basically, every tick, the arrow loses 1% of its velocity in every direction, um, because arrows don't fly forever, and air resistance will slow it down. And then you set that position, so then it just keeps drawing that ray data. And then by calling move tick in the method, like basically like 200 times, the mod traces out the entire flight path, and then the list of positions it calculates is then drawn on the screen as like the trajectory that we see. So here, this is actually where I injected my custom code. You basically just take the like all of the like the vectors and then just shove it into an array list and then just graph that. And yeah, that's basically how it works. Now, another thing is the reverse bow solver. This is just like predicting the path. Well, not really predicting the path, but like for this more for the auto aim feature. So this is a harder question. It's basically like we know where we want the arrow to land, on say a skeleton, right? So if you know like if you know I'm here and you're standing here, then what's the angle that we need to get here, right? What's the angle that we need to get there? This isn't that hard. It's just an inverse problem, because we will know like we'll know our force because obviously we're controlling the arrow in this case, of course. Um, so again, a direct mathematical formula to solve this would be pretty hard. You probably could if it's in Minecraft's code. I don't really want to do that because this stuff already exists. I basically just added a wrapper to it, which is kind of funny. So the mod does something more fun. It just kind of iterates over. So it uses binary search. So it's like if you have um, like a number from 1 to 100 and you don't know that, right? You can guess like 50, and then if it's too high or if it's too low, then it'll cut that in half, right? So let's say my number is 79, right? So this is higher, this is lower, right? So the number's not in that, so you go in that. So you cut it in half, so you have 50 and 100, right? So you go 75, right? 75, so you cut it in the middle again, and then you have 75 and 100, and then you cut that in the middle, so that's like like something in that, and then you basically close yourself into 79, and then that becomes the number, right? So the reverse bow solver basically does that, but instead of guessing numbers, it just guesses the launch angle, right? So let's go to So the reverse bow solver for the get y for the target. As you can see here, it is basically just like a shit ton of attempts, and it's going to set an initial search space because we know the vertical component of our launch direction has to be between negative um, 0.9 and 0.9. So this would be like aiming down and aiming up, right? So you would just like you'd either be looking like all the way. Let me draw this out. It's kind of bad. I don't know if anyone already knows this stuff, but basically you either be looking up or you looking all the way down. This is like 0.9. This is negative 0.9, right? And then it's just gonna be like it's just gonna slowly enclose onto the angle that it needs to hit the target, right? So it's gonna run this 50 times, which is basically enough to get your answer. Um, and then it needs a way to check this guess. So it kind of runs a mini simulation in the where's the new in the new y, right? So the get y distance method is just a simplified version of the physics simulation, um, and it'll just takes our guessed launched angle, which is vert here, and calculates how high the arrow is. So the new y, or like when like how high the arrow would be if it reaches the target's horizontal position, right? So here's like the crucial part um, of the code. It's if it's greater or if it's less than, right? So if the new y is greater than the target's vertical distance, then our shot went too high, right? So if it's if you know our target's vertical distance, right? So let's say we got a little piggy right here. I'm not very good at drawing pigs, right? But imagine that, right? And I'm looking out here, right? And I know that it has to be within this range, 0.9 to negative 0.9, right? Then we're just gonna keep iterating, right? And if it's greater, if we look back at the thing here, if the y is greater, right, then this targets then this vertical basically, then you need to half your search, right? So it would probably go like this, right? And then it'd say like, oh yeah, or actually, so let's say actually let's bring up this pig a little more. That's not the first thing I drew. Okay, so let's bring up this pig a little more, right? And you're here, negative 0.9 and 0.9, right? And it's going to go here and to say, okay, well, this is my upper, this is my lower, right? So then it wasn't the lower, so you cross it out, right? And then it's going to say, then now this becomes your new range, right? So it's going to go right here. It's going to go upper, lower. So then upper was eliminated, so now it's going to go lower. And then it may hit it right in the middle and be like, okay, cool, that's what we need to hit it at, right? So with every loop, the gap in the min vert and the max vert is cut in half, and basically by 50, um, it should hit it like in general, just because there's a bounding box, and if it collides with that, then you're good. Um, so yeah, now we got to put it all together. So the reverse bow solver has given us a 3D vector to aim at, and basically what you got to do now is just convert this vector back into a yaw and pitch that Minecraft can use um, to control the thing. And if you've ever used the mod, it just snaps towards it, which is kind of bad. So I probably need to fix that, but I'm not going to do that. So let's find the yaw. Where's the yaw? I think it should be. Oh, actually, no. It's an aimbow GY. So we need to take the yaw. So adjust the player's looking position. So you would take the vector and then just convert it back to yaw and pitch, and then there you go. So you've got it. So it really doesn't know the math. I wish it did. That way I could like write something about that. That'd be really cool and actually know that. But no, it just simulates it. So since we know the object itself, we can just simulate it a trillion times. And to do the opposite, we just you basically just guess. So yeah, I'm not very good at explaining this. I use ChatGPT to explain it, but some people like watching a video. I don't. All right, bye.